This is the lesson 2.2 visual summary, which is on ways for us to recognize direct variation. So yesterday we said that direct variation means that it has to be straight and run through the origin. So I'm going to kind of make a note of that. Those are two key things for direct variation. So we're going to make a few different graphs with different conditions and decide if it's direct variation. So the first graph we're making is we're going to make a graph that is going to be straight. It's going to go through the origin. So right away I'm going to put that point on there. I want it to be discrete, which means, remember, D for discrete means don't connect. So I'm going to just put some points in here that are straight. I'm going to go up 2 and over 1 and up 2 and over 1, up 2 over 1. I'm going to keep doing this. So hopefully you can see that these are straight. It does go through the origin. It's discrete. I did not connect. So I want to know if this is direct variation. So I have to answer two questions. Is it straight? Yes. Does it go through the origin? Yes. This is an example of direct variation. Common misconception is kids think that it has to be connected. Connected is just discrete or continuous. Has nothing to do with direct variation. Okay, let's try another one. This one we want it to be straight. We want it to be through the origin. So I have my origin. We want it continuous. Continuous starts with a C. Remember, that means we do want to connect. So I'm going to this time go, maybe I'll go up 1 and over 2. So I can see that that's straight. I see it's through the origin. Continuous means I need to connect. So when I want to connect, I want to use a straight edge to connect. So I'm just going to take the edge of paper here and line up my points. And I'm going to connect them. So is this an example of direct variation? Is it straight? Yes. Does it go through the origin? Yes. So it is direct variation. Next one. We want it to be straight, but not through the origin. Maybe I'll start it here. So if I want it not through the origin, but straight, maybe this time I'll go up 2 over 2. So as long as I'm doing the same thing each time, I get the straight. So I want it straight. It is not through the origin. I want it discrete, so I don't connect. I want to know if this is direct variation. Ask myself these two questions again. Is it straight? Yes. But does it run through the origin? No, it does not. So this is not direct variation. Okay, let's try another one. We don't want it straight. We do want it through the origin. So here, and I want it continuous. So I'm going to want to connect them. So I do not want it to be straight. So that means I'm not going to do the same thing each time when I move. So maybe this time I'll go up 2 and over 2. Maybe the next time I'm going to go up 3 and just over 1. Maybe I'll just go up 1 and over 3. Maybe I'll go up 2 and over 3. Maybe I'll go up 4 and over 3. So this is not straight, I can see that. It does go through the origin. They want it continuous, so now I need to connect these. So now we have to ask, is this direct variation? Has to be straight. Already there, it's not straight. Has to be through the origin. It is one of them, but it has to be both. Okay, this last one says it needs to be straight, not through the origin, and continuous. So maybe this time I'm going to do a straight line that goes the other way. It can't go through the origin, so maybe I'll start right here. Has to be straight, so I have to move the same way. I'm going to go down 2 over 3. Down 2 over 3. Down 2 over 3. Down 2 over 3. So they want it straight, not through the origin. They want it continuous. Continuous means I connect. So when I connect all my points with a straight edge, now I need to see if this is direct variation. It has to be straight, which it is, but it has to go through the origin, which it does not. So this is not an example of direct variation. Okay, now we're going to look at tables and see if we can figure out the same answer to the question of direct variation from a table. So what I'm looking for are patterns in a table. So I see that this doubled. This went up by 1, went up by 2, went up by 2. So what I want to see here is I need to back this up for 0. If I put in a 3, I'm going to set up ratios. I'm going to set up always the ratio of y over x to see if I get the same relationship. So right now, I know 5 over 1, which is 5. Let's try this one. 10 over 2 gives me 5. 20 over 4, I get 5. 30 over 6, I get 5. When I'm getting the same thing every time, this is called getting a constant. When I do y over x, this is called constant. Then I know when I get a constant that I will have direct variation. So if I want to back this up, this is telling me that 3 would be 1 times 5 is 5, 2 times this constant is 10, 3 times 5 would be 15, 4 times 5 is 20, 5 times 5 would be 25, 6 times 5 would be 30. So 0 times 5 would be 0. So I can see this would run through the origin. When it goes up at a constant like this, then I know I'm getting a straight line. So yes, this would be direct variation because it runs through origin. And because I got a constant, I know it will be a straight line. Let's look at the second one. So here, I can see it runs through the origin, but now I need to see if I get this constant. So I'm going to set up again, always y over x. So 5 over 1 is 5. 10 over 2 is 5. Now I can't just assume because I got it twice. I have to keep going. 12 over 3 is 4. 20 over 4 is 5. I did not get a constant because of this 4. So although it runs through the origin, it's not going to be straight. I need a constant to get a straight line. So this is not going to be direct variation. I can say it runs through the origin, but it will not be straight. And I might say here because I didn't get a constant. Maybe here I'll add it will be straight because I did get a constant. Okay, so let's check this last one. So I'm going to look for my constant here. I'm going to start 24 divided by 3, y over x, is 8. 18 over 2 is 9. 12 over 1 is 12. Right away, I do not have a constant. Does it run through the origin? No, it doesn't do that either, because origin is 0, 0. So if I were to graph this, this actually starts at 0, 6. So it would be something that would start up here already. So direct variation, no. Why? It does not run through the origin. And also it will not be straight because I didn't get a constant.